Under the current circumstance, many countries are setting up their own treatment centers for outbreaks and pandemics. These centers require hospital beds that are space efficient in storage, easy in transportation, and also need to provide comfort for the patient and the convenience for healthcare workers. That is why in this project we will design an enhanced portable ward bed for emergencies and disaster relief while being able to fold into a compact shape for storage and portability. Two types of mechanical systems will be involved in our design. First is a rocker slider with a translational input to adjust the angle of backrest. The second one is a 4-bar reverse crank slider with an actuator between linkage with adjustable length.
For bed design, we researched some human dimensions for a comfortable fit for our bed, and we use these values on screen, which are mean values for 95% of a man from US age 20 or above. The final dimensions of our bed has a length of 195 centimeters, with 47% of it being a backrest. The width would be 50 centimeters, and the total weight is approximately 30 pounds. With a safety factor of 1.3, it should be able to support up to 355 pounds of weight and should be able to raise itself up to 50 centimeters in height or down to 4 inches when collapsed. The whole frame will be constructed in 1-inch tubing with an exception of actuators, which is represented as an hydraulic actuators, but can be replaced with other forms of actuators.
Finite element analysis was conducted to ensure the safety of the frame and mechanisms. The simulations were conducted with a patient 355 pounds in weight and 195 centimeters in height, with a weight distribution based on averages. Simulations were done in the neutral sitting position and at 30 degrees incline. The materials used are 6061 1/8 inch wall and 1 inch by 1 inch tubing for the frame, and 1/2 inch steel rod as the hinges. Analysis showed some flex in the unsupported members of the backrest, but stresses remain less than 1/3 of the yield strength of 6061. Tests concluded that some additional support on the backrest may be warranted.
Using the SOLIDWORKS motion study, we were able to see how the mechanisms of the bed behave when the linear members move at a constant speed. This motion study simulates the angular movement of the bed's backrest by relating the angular movement to the linear motion of the actuator. On the left is a plot showing the angular velocity of the backrest. It starts high when the bed is in a flat position, but approaches zero as the bed reaches its highest incline. On the right is a plot showing the acceleration. It starts decelerating quickly at first, but slowly stops decelerating as the movement approaches zero. This inconsistent movement isn't desired in this application, but is acceptable because this mechanism allows the bed to fold into a compact shape. In order to verify our simulations, we did a loop closure analysis for each of the mechanisms on the bed. After isolating from the movement of the backrest, we found that the results agree with our simulation, that the backrest has a very high angular velocity at one limit position and a very low angular velocity at the other limit position.
For pandemic purposes, we want the bed to be mass produced, so we make it easy to assembly. Just have to weld some square aluminum beam together, and it costs around $600 plus labor for total cost, which is way less than a hospital bed frame, which is around $4,500 to $7,500. Besides mass producing, we wanted to make it so it's easy to transport and storage. The bed is designed so that it can be folded to reduce the surface area, and it is made out of aluminum, so it's very light. For future improvement, we want to increase the production rate, so we would like to have a more simplistic design so it can be easier to assembly and take less time.